right. Good morning. Good afternoon. My name is Eero Teerikorpi. I'm the founder and CEO of Continuum. And on today's Tungsten use case webinar, we are going to cover MySQL data protection. It is about how to run securely MySQL data in the cloud. And since Continuum, as you may know, is MySQL availability company, it is also going to be about availability, combination of these two. Couple words of myself before we get started. So how I qualify to talk about MySQL, MySQL Marketplace, MySQL solutions, and the MySQL ecosystem as a whole. I've been around, been involved with the 7 startups over my years, and kind of stumbled upon on MySQL Marketplace early 2002. Seems like a crazy. We got an idea to create the highly available MySQL clusters back in the time. It's as like looking from today's perspective is no brainer, but at the time it was pretty forward looking and forward leaning. Beside being called as a father of Continuent Tungsten, our main product today, I could be called as a godfather of Kalera as well. You may know Kalera, also known as the extra DB cluster. Continuum back in day, early 2000, created a solution called mCluster, which was also a synchronous clustering solution, but we felt that it didn't have the legs to go all the way where we wanted to go. And my team at the time then decided to take a different route, and they come to publish Kalera, which is a really good solution for what it does for local availability. But we had a vision for the much greater solution base. As you see from my picture, I'm also a sailor, actually a Navy officer back in days, and I like to run tight ship for the benefit of our customers, and to kind of make sure that everything runs smoothly. So how do we fit in on this whole marketplace? We've been around, as indicated, and we've seen the early days of open source and also the formation of the cloud computing. We started in US operation 2004. Today I'm joining you guys from my home office in San Francisco Bay Area. As you may see from the background image, that's my office overlooking the California hills. So we've been in the forefront of this wonderful creation of the new technologies and solutions. We had a foresight building a platform agnostic, something that runs on premises in the virtual environment and in the cloud, providing a highly available, globally scaling MySQL solution for business critical application. That was the mission. We started ourselves, and almost 20 years later, we're still on that. Continuent is not the biggest company on this field. It will never be. We are really focused what we do. But what we do, we want to be the best at what we do. And that's always been and will remain the focus. Today, use case, we are talking about one of our customers. You may have heard about them. You may not have heard about them. Modernizing Medicine, a small outfit from Florida. They run a solution for medical records. This company is basically leading electronic health record system, but they are specialty specific, meaning that they have a solution for the eye doctors and dermatologists and others, kind of a similar specialty areas, and manage the highly sensitive data. They started working with us a couple of years after the company got founded. It was 2010, the operation started. We got involved with them in 2012. Over the years, this company has grown significantly. It was way below $10 million at the time, both funding and revenue wise. And subsequently, as of today, they've raised over $300 million, pretty significant player on its own field. And why did Modernizing Medicine choose Continuum? So obviously, kind of looking from the kind of point of view, what do we actually offer? It is about availability. It could be about the data protection, scalability, cost. So that all of these could have factored in, or maybe it was all of the above. In this case, as many of our customers, we have quite a few software as a service vendors. It tends to always come to all of these options. Let's talk about them one at a time. Software as a service companies are inherently 24/7, 365 operation. So availability and being able to operate continuously is always on the forefront on their minds. In this particular case, because of the dealing with the health data, the data protection had a far more priority than the others. When you are running applications in the kind of demilitarized zones, there is sometimes a little less on issues with the data protection, but in Modernizing Medicine case, it's more because it was also running in the cloud. Scalability, all companies envision to scale software as a service specifically, and when you build these applications, you may have hundreds, thousands, even tens of thousands unique customers of your own, and you need to be able to build a solution to scale. And then cost is always a factor in. At the time, it was an easy solution when going back to early 2000, just pick the Oracle or Microsoft SQL Server, but those were cost prohibitive for many companies. And that's why open source gained as much of a traction in MySQL specifically as it did. So let's talk about those each. At the time, 2010, the cloud computing looked quite different than it today, but a lot of these same issues are present, especially related to databases and availability. And the lack of availability in AWS was the key challenge why Modernizing Medicine approached us. And we ended up solving that with providing them a highly available MySQL cluster, and then connecting that with another relay node. In some cases, some other customers will have a full clusters on secondary site, but in this case, it's a single node, just to make sure that the data remains secure and available. And how we dealt with that is that this is kind of a combination of the availability and scalability. When you build this product architecture, and then you create one of these, fill it in with the customers, and then you keep adding these additional pods as time goes by. So then the first cluster, 3-node cluster, provides you the availability. If primary fails, replica kicks in, and within seconds, sometimes sub-second, you have a new primary. And from a user's point of view, there is a slight hiccup and everything just continues. If there is a more significant event, the whole site is down, or can affect the region is down, there is still available another region, the relay node, that can basically take over. Obviously, that becomes a single point of failure, and it has maybe less of a performance if you only have a one node. If you would have a secondary full cluster, it actually would be the full-blown solution, and there is the node performance degradation or any other issues for the DR point of view. And then when you keep just adding this type of a combination, that the 3+1 clusters as you grow, and in this case, Modernizing Medicine, they have already 20 of these deployed across all of their hundreds of customers. And they basically have an infinite scalability using our solution. How do we solve the availability problem? Tungsten solution has 3 key components. It's a Tungsten Replicator, Tungsten Manager, and Tungsten Connector, as we call this. It's effectively an intelligent MySQL proxy. The key in many ways is in the connectivity level. Replicator keeps all these replicas in sync, so they are primary, obviously gets the updates. Replicas are just a few updates behind. and so that they're up to sync. And then Tungsten Manager monitors the cluster, and if it sees that something happens, for example, master failure, then in that case, one of the replicas comes in and replaces that and becomes a new primary database for the updates. Connector has a key role because it guides the traffic from the application, and if needed, it holds the traffic. For example, when primary fails, connector holds all the incoming traffic for whatever few seconds is needed, and manager coordinates with the connector and makes the changes on the cluster. And when the new primary has been promoted, then the connector releases the traffic again. From an application point of view, it has been seamless recovery from the failover event. Data protection. This was really one of the key elements with Modernizing Medicine, because it's a type of sensitive data. And in order to be HIPAA compliant, you have to make sure that the personal record information is kept secure. In the Modernizing Medicine case, and actually any company that this matter who wants to keep their data safe, they will use for all the internal communication, external communication, SSL. So the traffic is kept basically encrypted all the time, depending whether it's between the application cluster or whether it's inside the cluster. And on top of that, encryption at rest using the Linux operating system extension provides them ability to ultimately sign the necessary agreements with Amazon in order to run this type of a PHI information in the cloud. Without that, the cloud wouldn't have been an option, and they would have been forced to run this on premises. But for the good practice, they most likely would end up doing all the same things on premises as well. All right. Looks like somebody's trying to call me. This is not advancing right now. Hold on a second. Scalability. We discussed about a little bit of that scalability issue when we discussed about availability. Pod architecture, when you have a basically sharding based on the customers or practices in this case, means that you create these highly available tungsten cluster pods, and you fill in them with as many customers, depending on size of those, as you can. And that depends on the size of the computing instance and how much storage space you have in each pod. And then as you deem them to be full, then you create another pod and then start the process and signing up new customers. And when you do this in an automated fashion, like in Modernizing Medicine using Ansible, the actual deployment is practically automated and automatic, and in the cloud, it's really easy to build these tungsten clusters. For the management layer, Continuum offers a graphical user interface. This is a representation of one of the pods, and this is how it looks at when you have a multiple pods, basically managed through the same interface. Just to give you a little kind of glimpse what this looks like in reality, I have here access on the live clusters. In this case, that we have a single cluster. And for example, if we would kill the current master or primary on the pod 1, it fails. And on the background, we do automatic promotion. One of the replicas is now a new primary. And as you can see, it just happened in a matter of seconds. And this kind of how fast it actually happens depends on once again, compute instance size, and also the size of the database itself, and transaction load on the system. But in many cases, it's a sub-second event, and then in some cases, it takes seconds, but it seldom is any further behind. And now when we have one of the databases effectively out of picture, there's one primary, one replica available. If you want to reintroduce this failed node back in the system, we basically just use these UI tools and provide recover. And on the background, what happens is that the database is restarted and it catches up and then joins the cluster as a replica. And system is effectively up and running in a full capacity soon enough. We can manage these clusters either individually, or we can basically take a look at all of them at the same time. So let's wait the recovery take place, and then show the rest. As now the cluster is once again fully functional, one primary, two replicas. And if we take a look at all of the clusters, you can see the view. And it's kind of nice for you to see that basically which ones that are actively and ready, and just a quick glimpse what's going on the whole system. And basically that we can close and get an even tighter view that depending on how many of these you are managing. And when everything is green, everything is fine and dandy. Besides the failover, this is a great tool when you want to do, for example, maintenance operation. And typically the maintenance operation, you update, upgrade the replica first, and then when you've done whether it's the database upgrade, schema upgrade, or any other modification, when you're done with those, then you can effectively come here and, for example, in this case, promote DP1 as a new primary. And once again, all of this activity happens while the application is online. So you don't have to do this maintenance operation in the middle of the night during the weekends. You can do it basically on the fly, anytime, any moment. This is something what we call zero downtime updates and upgrades. All right. Cost is always a concern, no matter what kind of system you do, and specifically you run databases. Database solutions tends to be really expensive. When you use an open source solution, the cost on the open source itself can be zero, but when you start building a solution and systems, especially if you want to have a highly available clusters, there are some tools, open source tools available, but by the time you have put everything together and the way you have to maintain, it's actually no longer free. Either you do it by yourself, you hire a consultant, and then there is all kind of ongoing basically work that needs to be done. What we offer is a more complete solution, but we do realize that we are living in the open source realm, and our solution needs to match the effectively open source pricing at some level. So our pricing is non-linear. It means that yes, the initial jump is there, but the more you add in the system, the less expensive each additional cluster becomes, because you realize that there's less additional support for us and there's less additional value we offer, even if it's significant value for the customer, but the incremental value from the software point of view is not there. So that's why we offer a way the customers to level off the more they deploy. And then we like long-term commitments. Typical solution is annual subscription, but we have customers 2, 3, and even 5-year subscriptions. And obviously we keep them at significant price breaks on those. The other one, really important element of the cost is that we provide something called true-up. And when you sign up with the 1 year, 2 year, 3 year, we allow our customers to add additional clusters without any additional cost during that subscription period. So effectively, it's a kind of a site license or unlimited license up to the point the customer sign up. each subsequent subscription period. We don't require any license keys. We believe on our system. We trust our customers. We want to build a long-term relationship, and most of our customers are with us number of years. When we sign up the new customer, expectation is they are with us between 7 and 10 years. We have a customers well over 10 years already, and average customer age right now is 7 years, and it just keeps going up. So the reasons Modernizing Medicine chose to choose Continuum was around availability, data protection, scalability, cost. And the last but definitely not least is our support services. This is something that is not necessarily visible until our customers actually start working with us, but we aim to be by far the best on the industry on this front. We are not a MySQL remote DBA service entity, but since we have a deep MySQL knowledge, each team member has 20+ years MySQL, either DBA, site reliability engineering, or some other MySQL related knowledge. Whoever answers the questions is well equipped to deal with each situation. And what we are even more proud of it is how fast we do that. Over the past 2 years, the average response time to all of our customers across the whole plane has been less than 3 minutes. So not only you end up dealing with a knowledgeable person, but it's effectively immediate availability. We realize our customers run business critical application. There are millions, in some cases billions of dollars riding on our solution. So we want to make sure that we are available. Continuum effectively has 3 products. 2 of those we charge: Tungsten Clustering, Tungsten Replicator, Tungsten Dashboard. UI that you saw earlier is also part of the solution suite, but it's at the free of charge. That's a part of the subscription with us. Tungsten Clustering, it's about, as we discussed, about continuous MySQL operation. It's effectively zero downtime maintenance. You can run it anywhere, whether it's on premises, in the cloud. It could be hybrid of those 2. You can run multiple clouds. We have our customers running in Azure and AWS parallel. And you can build solution with geographic distribution of the solution. We have some gaming customers that has basically catering hundreds of millions of gaming users on a single cluster, which effectively is connected across the Asia Pacific, Europe, US West, and US East in a single backend solution. And having availability to be able to do the intelligent proxying with Tungsten Connector, you get benefits of the higher update performance and also the read scaling, significant read scaling. Tungsten Replicator, which is a core part of the clustering solution, has more capabilities than to be able to replicate data between MySQL instances. We offer solutions that can replicate into multiple targets. It could be, for example, Aurora, or it could be Redshift, HPE, Vertica, Hadoop, Kafka, and a number of others. So idea is that you can run your highly available operational database, and then you can, on the fly, in the real time, replicate that in reporting and analytics and data lakes and such, and without any extra performance hit on the primary databases within the system. This is not unlike Oracle Golden Gate in many ways for the heterogeneous replication needs. No, we do not offer a solution for Oracle databases, but we offer ability to replicate from any and all MySQL version, whether it's MySQL, MariaDB, Percona server, even from Aurora and HP Cloud SQL and Azure SQL MySQL. So those can be source databases, and then we have a number of variable target databases. And UI, you already see and experience how it works. Kind of a quick rundown the key benefits. We have discussed about this already, but as you see, I bring up the customer service as the number one. Once again, you wouldn't experience that until you would sign up with us, but us being available in minutes notice with extremely high knowledge level of the team, we provide a truly reliable backend for the business critical MySQL application. Cost saving, we realize that the MySQL and open source is free on its own. It may not be fully capable for the business critical needs. With our software solutions and with our support services, most definitely. We trust that, and many of our customers have trusted over the years. Obviously, once again, it is about continuous operation. That is what it starts from. Being able to run 24/7, 365, and being able to do the immediate failover. And we do that automatically locally, and it's automated fashion for the disaster recovery. We do not want to fully automate that process because we never know exactly what was the root cause that would require a site level failover. So we want a human intervention to take place there. We could automate that, but by design, we do not want to do that. One of the key elements for the software as a service, and practically any business users, to be able to maintain the system without any impact on their customers is highly valuable. And the fact that one can scale these systems, more and more companies operate not just in single geographic location, whether that's a single country, they tend to have a far more global reach. Modernizing Medicine currently operates in US only, but we have a lot of customers that break the geographic boundaries, that they have operation in US, Europe, and Asia Pacific, and being able to do this globally is really important and critical. And the fact that you can run practically anywhere. And not only that, you can easily migrate from one environment to the other. We have a number of customers started with the on-premises deployment and moved in the cloud without the downtime. We have customers running parallel in multiple environments. Or you can actually migrate from one cloud to another. A number of our customers are using this capability as a negotiation tool with the cloud vendor to get the better pricing for the computing instances. When you create a credible threat to be able to move from one cloud to another and do it seamlessly, it's a powerful tool for the pricing negotiation. Proxy is key, and it basically ties everything together. It provides the traffic management, and it also kind of makes sure that our cluster solution is as intelligent as it appears, and because it holds a lot of information and it communicates between the client application and the backend data services and maintains the availability all the time. And this combined with the replication services, being able to do it and take it to analytics, the reporting, and data lakes is important enhancement and extension. Last but least, here we are a MySQL solution. This is not a MySQL compatible solution like some other solutions out there. You can use whichever version of and variant of MySQL you want, MySQL, MariaDB, Percona Server, and you can also use any version of those. You can even mix and match them, not necessarily recommended by ourselves, but truly can do it so that they kind of sees the flexibility. And the fact that it appears we offer from an application point of view, the cluster looks like a MySQL database. There's no application changes needed. So you can plug this in on the existing environment without any real concern and consideration. Question, are you looking for MySQL HADR? Yeah, we like to sign up few new customers, obviously. So if you would be kind enough and send a chat window indication that are you actually looking a solution, maybe you already have something in place, but you're not quite happy with it, and you have something and you're still happy with it, we would like to learn what you are using and why you are happy, and if there's something that the areas that we might be able to help. And if this is something in the future, great, we'd like to know about that as well. And if you are here to educate yourself, that's great as well. Just please send us a little chat and we're happy to acknowledge those and then react as needed. As a recap, we are a continuous solution provider for business critical MySQL applications. Most of our customers are software as a service vendors. Some 70% of our customers are. We have a number of e-commerce, financial services, gaming, and telco customers as well. All of these have a 24/7, 365 requirement. Many of them runs millions of dollars. Some of our customers actually run billions of dollars businesses on top of our highly available MySQL clusters. And I can't stress this more. We are here to help, and we definitely make sure that we provide the best MySQL support partner on the industry. We've been together a long time, almost 20 years. Many of our people have a prior database experience, various databases, data replication, database connectivity, database clustering. Most of them have a 20+ years. Anybody customer interfacing, all of them have a 20+ years experience in running operational databases. And what we value highly is how fast we do respond. Few examples of existing customers: Adobe Sign. You may have used their e-signature service platform, fully running on Tungsten clusters. Marketo, another Adobe company. They have been us over 10 years and recently got acquired by Adobe for almost $5 billion. And you likely recognize companies like Garmin, which was dealing with the number of outage issues. Recently, those were on their Windows platform, and they actually are in the process converting some of those on Continuum platform as we speak. And then you can see companies like Riot Games, VMware, Vonage. So a lot of big companies are relying on our solutions. And why do these customers continue to rely on us year over year over year? It is the really fast and excellent support. We got 100% customer satisfaction rating on the most recent customer survey. I'm sure there's areas we can continue to improve, but the level that we have already achieved is pretty amazing. And what we value more is the customer renewal rate. Last year it was almost 100% as well. Obviously, over the years, some of our customers get acquired. They may have some other solution and new company that acquires them, and then it become obsolete. Or some cases, yeah, customers do fail. We had the recent IoT type of application, which looked promising, the company behind, but ultimately they concluded that it wasn't good enough business for them, and that's why we lost the customer. Nothing to do with us, but obviously the business realities matter. We've been around. There is one little side story back in 2014. We are kind of proud, even if it end up being what it happened. VMware was looking around at the time a company to build the database as a service solution for vCloud Air. At the time they were thinking about compete with AWS and Google and Azure, and they were looking for a company to help to build the data service solution on top of that cloud offering. VMware was looking around, acquired Continuum as the best of the breed solution and the best team. Subsequently, VMware decided that the vCloud Air was not the right strategy, and that was the reason that they refocused the effort. Continuum no longer was needed as a part of that equation, and we restarted Continuum, myself and my team, back in 2016, and we've been pretty busy since then, and we continue to be. The direction we saw the early days, we run today already in the cloud, but we have some visions how to make it even more automated as a part of our Tungsten Cloud initiative. coming out in the future. Thank you, everybody, for attention. If you have any questions, comments, now a good time to add those through your chat window. JJ, do we have any questions?
Yeah, Eero, thanks. There is a question here from one of our participants. The question is that they are MariaDB users, and they're just asking whether you could reconfirm whether Continuent solutions also work with MariaDB or the other MySQL variants, basically.
Yeah, most definitely. So obviously, MariaDB internals and functionality has separated from MySQL already over the years. But in many ways, the key interface is the pin log or binary log. And we are tapping into that to basically extract the data when an update happens. And then we are redistributing that using the Tungsten replicator so that and if there is any changes on the binary log basically structure, we naturally update that and then provide so that currently we do support all the versions of MySQL and basically all the versions of MariaDB as well.
Great, great. Thanks, Eero. And there is a question here on the intelligent proxy, which someone is saying they hadn't really heard about before. Could you elaborate on the concept a bit more, and maybe how does that compare maybe to other proxies? That would be great.
Sure. Yeah, the proxy is really kind of to build a abstraction layer between application and underlying data service, so that and when there are some proxies available like Proxy SQL and other similar solutions and open source MySQL, and what basically is a traffic call that they can tap in, look into the traffic, and then decide if it's an update and send it to primary database, or if it's at the read, they can send it to replica. But most of these quote unquote dumb proxies, they don't have a knowledge about the underlying cluster per se. There are some additional tools like an orchestrator that you can build in, but then you are responsible kind of building a solution that recognizes if there is a primary failure, for example, and reorganization of the cluster and promotion of the replica in the primary. And then there's maybe a manual step required to recover from that situation, so that these other proxies tend to work fine until something happens. In our case, what we call it intelligent proxy is the fact that the Tungsten connector or Tungsten proxy talks with the Tungsten manager. And when there is a failover event, master primary database fails, the manager sees that failure, communicates with the Tungsten connector, which then can put the traffic hold, and while Tungsten manager reorganizes the cluster and then communicates back, that then gives the information about which one is the primary, then the connector kicks in. And all of this happens pretty fast, sometimes sub-seconds, sometimes at a few seconds. But from the application point of view, there is no disconnect. Everything continues to operate as if there was a slight delay between the application and the database. That's why we call it intelligent proxy.
Great, thank you. And of course, if there are additional questions on that, feel free to ask them. I just see one more question right now, Eero, from a participant who's basically the question is, that the focus with this webinar was on AWS, but presumably there are other cloud environments that someone could be using also.
Yeah, we have our customers running in multiple clouds already today. Like Adobe runs the Adobe Sign in AWS and in Azure, so that you can run these effectively on any environment and even on parallel and can have communication to bridge. That's why we are indicating that the hybrid cloud solution. And this is kind of you can do that as a continuous solution, or you can do that for the migration. For example, if you have currently a on-premises deployment, you want to move in the cloud, the way it happens, we would set up initially a cluster on the on-premises, basically let that run for a while. Then we would create the identical cluster in the cloud, have a intelligent proxy sitting in front of both of these two cluster instances. These proxies actually are not just locally aware, they are globally aware, so that they don't only see the one underlying cluster, they see them all. And then when we basically connect these two clusters as a composite cluster, they basically become a one. And then you can at one point decommission the on-premises cluster and just keep using the cloud. So everything, once again, from the application point of view, because we are isolating the application from the underlying data service, it looks like a single MySQL database, even if in our case, it can be quite complex. We offer solution for the single clusters. We have a solution for cluster of clusters. You can do that in such a way that one cluster is active and the other or others are passive. So then they become a DR cluster and read clusters. This is, for example, Riot Games. They have one active cluster and 3 passive clusters providing local reads. And then if you want to take it in one step further, you can have all of these clusters to be active. So effectively you allow updates taking place locally, increases the overall performance, once again, in response times. And then in the back end, we communicate in such a way that all of the clusters are ultimately up to date across the whole data service, whether there's 2 clusters, 3 clusters, 4 clusters, or more.
Great, thanks, Eero. And I don't see other questions just for now, but we are recording this webinar, of course, and we will be making the replay available. So if there are questions, then we're always available to answer them, separately also. But I think we're kind of coming to the time to close the webinar. Eero, if you have some, closing words.
Yeah, thank you for joining us today. And as stated in my picture, smooth sailing. Join with the Continuum team and expect a nice, smooth run. Looking forward to discuss with you all at some point and form down the line. Bye now.